Let's do this. Welcome to another video. With the last one, we started to talk about lighting, and today we'll start to talk a little bit about animation. Now, in due time, we'll do a proper dive into animation, and we'll cover everything that you need to know about its principles, and as well, all that you need to know about camera movements. Here, I'm talking about some kind of like arcane Spider-Verse kind of level of animation. In due time, we'll get there, but we are not there yet. In fact, this will be a simple and shorter video that sorts of complements the previous one, where we took a first look at the 3-point lighting system. Now, like we said in the previous video, the role of a light is kind of tied also to our view as an observer. And so if we want to start making a simple animation with 3-point lighting systems, we also need to understand how to lock in the lights with the camera. So for this video, I went back to our coffee maker scene because it is lighter in terms of geometry and computational cost. And so it allows me to show you what is happening at render time while also recording. So here I have set up a Limbo background, a camera, and 3 lights, just like I showed you in the previous video, and also an HDRI with a very low intensity. Now, if you remember in video 11, you created your very first basic animation, although that was really a sort of kindergarten experience where all we did was rotating an object while keeping the camera static. Today, we will move our first step into cinematic animation by figuring out how to move the camera. And it is all rather simple. So enter parenting. So what we are going to do is that we are going to create an empty. Now, the kind of empty that we are going to create is a sphere. This is my favorite way to go about it. Given the size of this scene, maybe we can pick up something like 35, something like that should be just fine. Now, an empty is an empty object, right? We covered this in a previous video very briefly. We also said that any object, any primitive mesh, once you open it up in edit mode, if you delete everything inside, it ends up being an empty object. Now, empties as true empties exist in many forms and shapes. This one is a sphere, and it is used in this case because it conveys very well the way in which it is rotating. Still, despite being empty, right, it can still have rotation information, and that is what we're going to leverage. Now, one pro tip is the following. Once you have set up your camera in a place that you like, and if you remember in the previous video, I showed you that you can use the 3D cursor option and the camera to view option to sort of like move your camera view in a way that is aligned with your current view, so you can move in a very natural way. Once you are happy, you want to turn this off, right? But so many times you will forget to do that. And so what will happen is that you have worked super hard to find just the perfect angle, and then you forget to take this off, and next thing you know, you knock the camera off, and that is something that you cannot undo with Ctrl+Z. That is just lost, and then you will have to be very patient, very zen, and just reposition the camera again. Now, to avoid all that ruckus, what you want to do is go to Item and click on this lock icon, both for the location and rotation of the camera, so you're kind of like in a safe space and nothing is gonna disturb it. Now that the camera is safe and sound, what you want to do with the camera selected is Shift select our empty. And if you remember from one of the earliest videos, we now know that the empty is the active element because it has the bright orange selection. And then I'm going to right click parent and parent object. Now, if you notice in the outliner, now the empty has a sort of drop down option, and we see that the camera is referenced here because now the camera is parented to that empty, and I'm going to rename that empty rotor. So I often call it rotor because I use it to rotate the camera, but this is fundamentally the idea of a boomstick. So it is like if you have attached your camera to a boomstick, and now when you move the boomstick, it moves the camera. So if I now move my boomstick rotor, as you can see, they all travel together, right? Now this is great because you have something that is absolutely zeroed out, and at the same time, you have this information about your camera that is locked in. And so you can move your camera around without having to worry about changing these things. It is a little bit like the delta transformation, if you remember when we talked about those, with the added advantage that this is something that you can use to achieve more complex motions, but we'll see that way into the future. Now, if I press 0 and I start to rotate the Z of my rotator, you will see that now we are rotating around the object, right? However, we now have the problem that we discussed in the previous video, that as you move your view, the lights are not following. And so what you have set up as a rim light will no longer be beyond the object, and so it will no longer work as a rim light. Now, that can be totally a possible scenario. It can be a light that is static, but say that you wanted to have the lights locked in and constantly have a rim light that sort of moves with your camera. Then what you're going to do is select your lights, just like I did here. And then once again, we're going to select last our rotor. It is very important that we select as active as last the object towards which we want to parent our objects. And then once again, right click, parent an object. And now you will see that the rotor is also referencing the 3 lights. Now, when I rotate my rotor on the z-axis, the whole system follows. And so the last piece of the picture is, of course, the limbo. So we can avoid a situation where the limbo sort of gets out of the picture and we start to see the HDRI that we do not want, in this case, in our frame. So I'm going to bring back the rotor to 0, and one more time, parent the stage to the rotor, right click an object. And now this object, this empty, commands everything in my scene that needs to move except the subject that, of course, I want to have still. So now if I rotate the rotor, we have the appearance of the coffee maker moving, okay, but in truth it is us who are rotating around the object. And this ensures that our lights stay consistent. And here is how it would look if the HDRI was completely turned off. And now, as you can imagine, we only need to animate this value over here, and we have ourselves our first animation with a camera movement. So what we're going to do over here is the following. We will once again change our end frames to 360. We are now at frame 1, and we will press I on the rotor rotation, and now we have keyframed it, so now it is yellow. We will then click on this icon, which will jump to the endpoint, and now we are at frame 360. And now Blender, it's telling us that this value has keyframes, but not for this specific frame. So we will turn this to 360, press I, and now we have ourselves a rotation. Now, like as mentioned, in due time, we will cover things like the principles of animation and things like easing, which is when you start slow, accelerate, and then slow down again, which if I play the animation, you will see that we slowly start to accelerate, we reach a peak of rotation velocity, and then we slow down again, just like we did in our previous animation. However, if we wanted this to be a very nice loop, we would have to press A while hovering over the timeline, T to set the keyframe interpolation, and we would set it to linear. And now everything just moves at the same velocity all the time, and this creates a perfect loop. So when we get to frame 360, we should actually move to 359 as the last one, so that the next frame is frame number 1, and now we have a perfect loop. Cool. Now, to render it out, you will go to the Render tab. You have the option of using either render engine. We haven't covered this yet, but so far you only need to know that Eevee is kind of a render engine that is great for stylized things. It is less computationally expensive. It takes usually less to render in Eevee, but it is also less accurate in terms of realism. Whereas if you switch to Cycles, which is the other render engine, make sure you are in GPU compute, so you're using your graphic card, and as you can see, everything now looks a little bit more realistic. In the Printer tab, you will want to set your frame rate, the percentage at which you would like to render. This is up to you and the specs of your machine and how much time you want to commit to this render. I only want a really simple preview, so I'm bringing this down to 25% of this dimensions. And then you have to define a final directory on your machine where you want to save the thing, and make sure you change the file format to FFmpeg video. This is your conventional MP4 format. And then what you want to do is go to Render in the top left corner and click on Render Animation. Do not click on Render Image, otherwise you will render just a single still frame. Alright, so that is it for this video. We have successfully created a simple animation that has some camera movement. This specific animation, which is a perfect loop, is known in the business as a turntable. But as you can see, there is still a lot of room to improve to make it look realistic and to make it look overall better and more interesting. And so make sure you don't miss the next few videos, because we will be discussing exactly what is still missing and what are the steps to actually get there. And also, since in the previous video I showed you a character, Jinx from Arcane, in the next video I am going to show you a very simple way to get started with characters and have fun with animation, lighting, and characters all together. Cool, I'll see you in the next video.